Hello, this video is for Mrs. Rose's AB Calculus class on natural log integration. Okay, so to review briefly, we've already learned how to integrate with the anti-power rule. And of course we add 1 to our exponent, we multiply by the reciprocal of that new exponent, and we have plus c. The antiderivative of integration is exactly what you would think of if you take the derivative and you go backwards. So if we take the derivative of natural log, which is 1 over x, then the integral of 1 over x dx is the natural log of the absolute value of x. Now, the absolute value part is important because the domain of a natural log function is 0 to infinity. It does not include 0 or negative numbers. So you have to have the absolute value piece to make sure that it fits the domain of the function. Now let's do some examples. Okay. So similar to our use substitution problems, if you can rewrite a function in terms of 1 over u du. Our integral is going to be the natural log of the absolute value of u plus c. And similarly, if you have a coefficient, we know what to do with those. We just take the 2 and we bring it to the outside, and then our integral is 2 natural log of the absolute value of x plus c. Now this one, to use the properties of natural log, you can take a coefficient of 2 and make it an exponent, which becomes natural log of x squared plus c. And when you have this, you no longer need the absolute value because, of course, x squared is always going to be positive regardless of your input value. For our third example, let's look at 2 over 4x minus 3. And when you have something like this, you really should make whatever your denominator is u and then do a u substitution problem. So if we do that, our du is going to be 4x. Now, when you have 4, when you have a 2 but you need a 4, if we just multiply our numerator by 2, then we get the number that we need. But again, you can't just multiply by 2. You have to balance it out somehow. So we'll do a 1/2 in front. And then, when we go to rewrite it in terms of u, we have our 1/2 integral of 1 over u du. And then we just integrate it like we normally would, where we have 1/2 natural log of the absolute value of u plus c, and I just plugged in what u was when I took the absolute value. Finally, if you take that coefficient of 1/2 and bring it up to the exponent is 1/2 is a square root, so we get natural log square root of 4x minus 3 plus c. For our fourth example, we have the integral of x cubed plus x underneath the 3x squared plus 1. And again, like this one before it, we're going to use a u substitution and have our u be x cubed plus x. And then our du is going to be, of course, 3x squared plus 1 dx. So our entire numerator times the dx is going to be du, and our entire denominator is going to be u. So we have 1 over u du, and then of course the integral of 1 over u is going to be the natural log of whatever u was in an absolute value. Okay. Our fifth and final example, we have the integral of 2 over 3x plus 2. So like the other two previous examples, we're going to make our denominator u, and then our du is going to be 3 dx. Well, we don't have a 3 on the numerator, we have a 2, so we're going to have to multiply by 3 and multiply by 1/3. So when we go to rewrite it, the 2 is going to be brought out with the 1/3, and the 3 and the dx are going to be our du. So we 2/3 integral of 1 over u du, which of course equals the 2/3 times the natural log of the absolute value of u, or the 3x plus 2 plus c. And that's it for this video. See you in class.